15 January 2022. The South Pacific Ocean looked calm. Satellites drifted silently above the Earth. People across the island nation of Tonga were going about their normal day. Then, without warning, the planet released one of the most powerful explosions ever recorded in the modern scientific era. Not a nuclear weapon, not a meteor strike. A volcano hidden beneath the ocean had just awakened. Within minutes, the sky turned violent, the sea began to withdraw from the shore, and a column of ash and steam blasted upward with unimaginable force. This was the eruption of Hunga Tonga Hunga Haʻapai eruption, an event so powerful that scientists would later confirm the atmospheric shockwave circled the Earth multiple times. What happened that day was not just a volcanic eruption, it was a planetary scale event. Far beneath the waves of the Pacific sat a volcanic structure known as Hunga Tonga Hunga Haʻapai. Most of it was underwater, rising nearly 6,000 feet from the ocean floor. Only two small islands were visible above sea level, rough, black volcanic land formed by previous eruptions. For centuries, this volcano had quietly shaped the region, but in the late 2010s, scientists began noticing increased activity. Between 2014 and 2015, an eruption created a brand new island. Researchers were fascinated. Some even believed the land could survive for decades. They were wrong, because the volcano was not calming down. It was building pressure. In the weeks leading up to the disaster, smaller eruptions sent ash clouds into the sky. Ships were advised to stay clear. Aircraft were rerouted. Yet nothing suggested what was about to occur. Then came the morning of 15 January. At first, satellites detected a rapidly expanding plume. Within moments, instruments began recording something extraordinary. The eruption generated an atmospheric pressure wave so strong that barometers thousands of miles away registered a sudden spike. Meteorological stations in places as distant as Alaska recorded the disturbance. Scientists would later describe it as a once-in-a-generation atmospheric event. When the volcano finally unleashed its full force, the blast shook material more than 30 miles into the atmosphere. To understand that scale, commercial airplanes typically cruise at about 7 miles above Earth. This plume went far beyond that. It punched into the mesosphere. From orbit, where the satellites captured an image that stunned researchers, a gigantic mushroom-shaped cloud spreading across the Pacific. Many compared its appearance to historic nuclear detonations, though this was entirely natural. The energy released was estimated to be hundreds of times more powerful than the atomic bomb dropped on Hiroshima. Yet, unlike a weapon, this explosion came from deep within the Earth itself. The eruption was not only seen, it was heard.
Oh, fuck! Holy shit!
People in parts of Australia reported a distant thunder-like boom. Residents of New Zealand described windows rattling. Some initially believed a massive industrial accident had occurred. In reality, the sound had traveled thousands of miles across open ocean. Such long-distance acoustic propagation is extremely rare, a reminder of just how violent the eruption truly was. Perhaps even more astonishing was the atmospheric shockwave. It raced outward at hundreds of miles per hour, forming a visible ring captured by satellites. Then something almost unbelievable happened. The wave continued traveling around the globe not once, but multiple times. Each pass was detected by sensitive instruments. For atmospheric scientists, it was a historic dataset, the clearest modern example of how energy can ripple through the entire planetary system. The Earth had effectively rung like a bell. While the sky erupted, a second danger was already forming. Tsunami. Near Tonga, witnesses saw the ocean pull away from the shoreline, a classic but terrifying signal. Moments later, waves surged inland. Boats were lifted onto streets. Homes were flooded. Infrastructure was torn apart. But the danger did not stay local. Tsunami waves crossed the Pacific. Warnings were issued in Japan, the United States, and parts of South America. In California, harbors experienced strong surges that damaged vessels and docks. For an eruption thousands of miles away to trigger measurable effects across an entire ocean basin is extraordinarily rare. Soon after the blast, communication with Tonga became extremely difficult. Why? Because the eruption severed the single undersea fiber optic cable connecting the country to the global internet. For days, the nation was digitally isolated. No reliable calls, minimal data, limited updates. The world watched satellite imagery, trying to understand the scale of destruction while families abroad waited anxiously for news. It was a stark reminder of how dependent modern societies are on fragile infrastructure hidden beneath the sea. On the main islands, ash began falling like heavy grey snow. It coated rooftops, contaminated drinking water, and damaged crops. Breathing became difficult in some areas. Vehicles struggled to move through the powdery layers. Volcanic ash is not soft like fireplace soot. It consists of tiny fragments of rock and glass capable of harming lungs and machinery alike. Airports closed. 8 flights were delayed until runways could be cleared. Every hour mattered. Most volcanic eruptions occur on land. This one was different. It happened in shallow water. When magma rises rapidly and meets seawater, the interaction can become violently explosive. Water flashes into steam almost instantly, expanding with tremendous force. Scientists call this a phreatomagmatic eruption, a technical term for one of the most energetic volcanic processes known. But there was another factor. Researchers believe part of the volcano's structure collapsed during the blast, allowing even more seawater to rush in. The result was a chain reaction of explosive energy release. In the months that followed, scientists made a surprising discovery. The eruption had injected an enormous quantity of water vapor into the stratosphere. Unlike ash, which typically cools the atmosphere by reflecting sunlight, water vapor can trap heat. Some climate researchers began studying whether this event might temporarily influence global temperatures. It was a rare example of a single natural event with measurable atmospheric consequences. Not just locally, globally, because most of the volcano lies underwater. Understanding exactly what happened is challenging. Mapping the seafloor requires specialized sonar equipment. When research vessels finally surveyed the area, they found dramatic changes. Huge sections of the volcanic cone were simply gone. Where land once stood, there was now open ocean. Nature had rewritten the map in a matter of hours. Volcano prediction remains one of geology's greatest challenges. While warning signs existed, the precise scale of the eruption surprised many experts. Submarine volcanoes are particularly difficult to monitor. You cannot easily place instruments on them. Visual confirmation is limited, and pressure builds out of sight. This event has since accelerated efforts to improve underwater monitoring networks worldwide, because the next eruption may not occur in such a remote location. Remarkably, the loss of life was limited compared to the scale of the disaster, thanks in part to the distance between the volcano and heavily populated areas. Even so, communities suffered severe damage. Homes were destroyed, fishing boats vanished, freshwater supplies were compromised by salt and ash. Recovery required international assistance, with neighboring countries sending relief shipments and technical support. For a small island nation, resilience became the defining story. For researchers, the eruption opened a rare window into planetary dynamics. They analyzed satellite data, atmospheric readings, acoustic recordings, and ocean behavior. The event is now considered one of the best documented eruptions in history. It demonstrated how interconnected Earth systems truly are: ocean, atmosphere, and geology interacting in real time. No laboratory experiment could replicate such complexity. Only nature could. Modern cities glow with electricity. Aircraft cross continents overnight. Information travels instantly. It is easy to believe humanity controls its environment. Then the Earth reminds us otherwise. Deep below the surface, tectonic plates continue their slow collision. Pressure accumulates, heat rises, and occasionally the planet releases that energy without negotiation. The eruption was not malicious, not intentional, simply geological forces operating on a scale far beyond human engineering. The Pacific Ring of Fire, a vast zone of tectonic activity, contains hundreds of volcanoes. Many are underwater. Most remain poorly studied. Events like this push governments and scientific organizations to invest in better detection systems, tsunami warning technology, and satellite monitoring. Preparation does not stop eruptions, but it saves lives. If there is one image that defines this event, it is the satellite photograph of that immense plume rising above the curvature of the Earth. Beautiful, terrifying, a reminder that even in the age of space exploration, our own planet still holds the power to shock us. The eruption of Hunga Tonga Hunga Haʻapai was more than a regional disaster. It was a global signal, a demonstration that the ground beneath our oceans is alive with forces we are only beginning to understand. It disrupted the atmosphere, moved entire bodies of water, and briefly isolated a nation from the world. Yet it also showcased human cooperation, scientists sharing data, countries delivering aid, and communities rebuilding together. The Earth is not static. It is dynamic, restless, and extraordinarily powerful. And somewhere, right now, beneath dark ocean waters, other volcanoes are waiting, silent, pressurized, unseen. The question is not whether the planet will produce another massive eruption. Geology guarantees that it will. The only uncertainty is when. Subscribe to Nexra for more real stories.